Hi there, my name's Vince from My Mate Vince, and this is just a very quick revisit video, a bit of a recap of some of the previous fixes and also an error as well on this thing here. So let me just go through a few of them nice and quick just to keep you up to speed. So do you remember the blender? With this blender it exploded in my face because I connected the polarity wrong. I didn't realise there was a little positive here. I thought DC motor is not going to make a difference whether it's which way round it goes. Now, apparently with DC motors, no, it doesn't make a difference. A few people did say that it can make a difference. To make a DC motor last longer, if it's going to be going around in one rotation all the time, which on a blender it is, then the brushes can be slightly angled like this. So instead of being straight on like this, they can be angled like this, and apparently then the rotation, hold on, if it's this way, the rotation would be this way, yeah? So you can see even just with my finger there, it's just knocking it nicely, rather than if it was dead straight, I suppose there would be more wear than if it was on it like that. So it is possible to have them directional, but generally speaking, no. What people are saying is the reason that this failed is the original fault was a shorted motor, and that's what blew the fuse. Now, when I replaced the fuse, what's going on here now? The fuse. Oh, I unsoldered it again, didn't I? I just jumped over the fuse here. So the fuse here is blown. I put a fuse in the back here. So obviously I put power back into it. But the thing is, the motor short was still there, and that's where the boom came from, because the motor itself has failed. The general consensus is that the fault on this was the motor was the original problem, which then blew the fuse. So me changing a fuse didn't actually fix the problem, which was the motor. So yeah, that's why we had that spectacular sort of fireworks when I changed the fuse and went to turn it back on again. Another thing that was interesting of note is, obviously there's a lot of torque in these, and I kind of had it turned on like this, like wedged in between this and this. Well, that was extremely dangerous, because what could have happened is, if it was to work, the torque on that could have easily flipped it up, and that could have then landed in my lap, and this is 240 volts in here, and it would have given me a very, very nice shock. So yeah, note to self, ever working with motors in the future, don't just rely on kind of like wedging them in place with something lightweight. So yeah, that's that one there. Annoyingly, bad news. Look at that, the wires have just come straight off. Bad news. How annoying is this? You know, like, we often drop our phones, and sometimes we can be unlucky, but if we're honest with ourselves, we probably drop our phones a few times a year, and normally we're okay with that, aren't we? Things are still working. You'd be a bit hard done by to drop your phone and for it to stop working. Well, this is my camera, £600 camera, still a £600 now, and yeah, I've been using this for the last couple of years, and basically I was taking it from my desk here to where I edit, and it's just laminate floor, so kind of soft because it's like, you know, fake wood with a load of sponge underneath it. It fell from waist height because I was just carrying it like this. Don't know how, dropped out of my hands, landed. When it landed, it made a bad noise, and I thought, oh, that doesn't sound good. Went like that, went to turn it on, and it was working. Anyway, when I went to use it the next day, it doesn't recognise the SD cards. I did actually film me trying to take it apart and stuff. Look how complicated this thing is. It's got nothing to do with the SD card reader. It's something to do with this board down here. This board has a ton of BGA chips on it underneath this side here. So annoyingly, there's something majorly gone wrong with it. I just wanted to show you the gimbal here. So if you have a look, this has one of these stabilization gimbals. Yeah. So when your hands wobble in, or you know, you're walking along, it stabilizes the image. It's supposed to work really well. Do I need a gimbal? No, because you know most of my filming is just done overhead, but still sometimes I do a bit of handheld, so it might make for slightly smoother filming. But look at the size of that. How nice is that? This thing here is just, I take apart quite a few things, but nothing compares to things like cameras. They're super, super complicated, and compared to like the DSLR that I took apart before, the Canon one, this is just next level stuff again. Everything is so complicated. Even trying to take it apart, the screws and everything are on the wrong side. You know, you expect to undo it from this side, but you're trying to reach in from here with a flexible screwdriver to get it undone. Really weird how it's been put together. But yeah, look at the size of that from there to there. Absolutely huge. So yeah, annoyingly, I had to buy myself a new camera. I can't be without a camera. So yeah, had to buy another one for £600, which is a real kicker. But it's one of those things where, yes, I was heartbroken, but I need to turn my brain off to that and just think, Vince, get on with it. It's happened. There's nothing I can do to change it. It's happened. Don't even think about it. Turn my brain off to that. Get a new one and just get on with making videos. And then after a few videos, I would have made the money back on that anyway. So that's that one. Now, this one here. Do you remember this one had a blown chip on the inside? Let me just take it apart. What a lot of people said is, it's amazing what people spot that I miss. They said that this was the one with the blowhole in it, yeah? So if you have a look, this chip, they're both the same chip. This chip is to feed this HDMI port, this HDMI port, and this HDMI port. And everybody said that this chip is to feed this one, and this one. The only problem is, if you have a look, this here is the output. So this is different than all the others. All the others are the input, but this is the output. And if you have a look, the output one, which is labeled up there, output, actually goes to this chip here. So it's not as simple as just removing the chip, because you see the output one needs to be connected to the legs at the bottom of this chip here. So what happens is both chips are linked via this side, and then it travels down to the output. So what I thought is, well, to begin with, there was numerous things wrong with this one. There was actually a shorted capacitor up here. I did actually film this, and to be honest, it was kind of interesting. I'm just sort of thinking, is it worth editing up a couple of hours video for something where I can just explain that it failed? But yeah, basically, there was a shorted capacitor here. I thought if I was to take, because you see, we don't have to have this one working or this one working, but if I could have had this one, and this one working, then you see it would have still been usable in its own right. So what I did is I had to cut some of the traces that were fed from here to this side. And then all the ones down here are actually fed from here. So from here they go to this chip and then down to here. So I jumpered a load of wires, and that took me ages to go from there to here. But unfortunately it still doesn't work. So I get more life in it now, but it's not being recognised on the TV. So if you have a look, if I put power into it, you will see it will liven itself up. There you go, you can see we've got lights here now, but yet when I connect it up, it's still not being recognised as HDMI. So yeah, slightly unfortunate there. But still, it was worth a try, and it was a good idea in the comment section to remove that chip to see what's happened. Right now, Sega Saturn. Do you remember on this one here, I had a fault with the kind of, I'm going to call it the voltage regulator, but part of the power supply. And I put a load of thermal paste on it because I thought it's going to provide a better contact between that and the shield at the back. But originally it didn't have any thermal paste on. I thought that maybe it was kind of penny pinching, or whether it was just too much effort that it wasn't necessarily needed. I thought by putting thermal paste on I was doing a better job. Well, as it turns out, looking at this comment here, there's supposed to be conductivity between the item I replaced and the shield at the back. And basically by me putting thermal paste on, my thermal paste is non-conductive, which is good. That's normally what you want. But of course it means it's not going to conduct with the plate at the back. So what I did on this one is basically I took it apart again and I removed all the thermal paste. So now it is just the item up against a heat sink at the back, and it will be electrically conductive between the item and the heatsink. Right, Vince just jumping in from the future here because it'll be easier just to show you and explain. So this was the thing that had a load of thermal paste behind it, so that's all been cleaned now. So basically the back of the chip is making electrical contact with this heat sink here. And a couple of other things. Lots of people mentioned that this resistor down here was blown. Let me just zoom right in. In this instance it wasn't blown. What it was is, if you have a look, can you see the 6 here? The top of the ink had just hit the top corner, and there was a black mark on it. It was just from the ink from where the board was stamped after production. So yeah, a bit of IPA and that cleaned up. But this is an interesting one. A comment from Solderbridge said, has nobody mentioned the crack in the board between R103 and this capacitor 106? Sure enough there is. Can you see there? Look here, a crack. Forget about that, that's just flux from where I was soldering. But look, there's a crack between there going up here. But if you actually look underneath it, there is no crack. But yeah, the board is definitely cracked, but you can see it hasn't actually gone through the traces. So in this instance, it's not going to cause any bother. And but I mean, it is a weak point, and the reason it's cracked there is because when you take the power supply out, there's a little catch just here, and that's exactly where it cracks, you see, because you need to loosen it up before lifting it up. If you try to pull it from there, it's going to be stuck down and the board's going to be flexing. So yeah, that's the story of the Sega Saturn. Let's move on to the next one. Now, lastly, I did a little T-brake fix on this item here, which is a little USB amp meter. And I was slightly confused because the maths didn't work out with my resistors. I had to put another resistor in over it. Anyway, the comments came in, and a couple of comments said that, Vince, you've wired in the voltage regulator wrong. And I mean, you know, I'm normally quite good at wiring up stuff because my background is telecoms. I normally don't get those sort of things wrong. And I thought, no, that's completely, you know, I thought, no, that's wrong. I've definitely wired it up right, because I remember getting the pin out and bending all the legs in place. Anyway, you know, I have to, if there's questions saying, if more than one person says, Vince, you got it wrong, then you need to start paying attention. So I look back at the video and I just can't believe it. I've wired this in wrong. So the voltage regulator here, where it's voltage in, I've got it as voltage out, and where it's voltage out, I've got it as voltage in. I can't believe that. So I was shocked when I seen that, because I was sure I got that right, but somehow, I mean, don't want to make excuses. I have had bloody bad flu, and I'm still overcoming it now. In fact, I'm going to be going on to antibiotics. 2 weeks I've had flu now. So, you know, waking up just wet t-shirts the whole time. So I don't know whether that was playing with my brain. I mean, I have had quite a lot of brain fog, but yeah, I wired it in wrong, which is really, really embarrassing. So I'm just going to finish up this video now. I'm just going to get another voltage regulator, because on this one, as I've been wiggling around the place, I've now broken off the ground leg in the middle, and I'm going to wire it up correctly. And I just want to see now, without this resistor in parallel, whether or not we have it nearer 5 volts. So next time you see this, I'll have a new voltage regulator on it. Okay, so I've got that all connected up the correct way now. Do you know what? Even when I was doing that there, I started to get confused, because the thing is, you need to remember to look at it from this side down. So for example, now it's going to be the same as that way. So voltage out is on the left hand side, so you can now see that it's going via the resistive divider, and then I've teed in the middle of the resistors to go to the output. So now on this point up here, we should have around about 3 volts. So if we plug that in there and go between here and that capacitor, there you go, 2.925. Yep, the resistors I went for in the end. The problem is, it gets more complicated because, like others mentioned as well, when it gets connected into the circuit, the chip and stuff will put extra resistance in it. But this is what I did. So I did 3.3 was coming out. I did 12 ohms for the first resistor, 120 for the second, and you can see that should output 3 volts there. And if I go, well, it's going to be the same, isn't it? It's going to be the 2.9. Because if I go between here and here, you can see there 2.9. So it could do with being a little bit higher, but I don't really know how you would calculate the resistance of the chip, you know, the rest of the circuit. I don't know. Anyway, if you have a look, you can see now we have 5, a little bit high, 5.3. What's this one? Remember, I have ordered the correct chips anyway, so this is kind of pointless. 5.18. It's not a million miles off. And if we plug one into the other, you can see there the voltage is quite a bit different, but yet the amps drawn are very similar. So I think it could be used in a bit of an emergency, but I've got the correct chip on its chips on its way, but I've got 50 of them. So yeah, when I pop that in, it's all going to be working fine again. The bald head machine, the hair recovery machine, must have just put some instant kind of too much strain on it or something, and it must have just blown that chip. Really weird. It could be just coincidence, but that is it. I'm slightly embarrassed that I managed to wire that up wrong, but the thing is, I always like to be corrected, because that's how I learn, and that's how other people learn, watching watching these videos. And because let's face it, if you wanted to know the ins and outs of stuff, you're probably not going to be watching my channel. I think you're watching my channel because you're kind of learning along with me. Similar to what you would do yourself. So I suppose the lesson learned is to double check your work. I was sure that stuff like this is quite basic for me, and I'm not talking about electronics, but you know, getting things like this in the right order. So I am embarrassed by it, but at the same time I'm glad that I've been corrected, because it's you know, to err is to be human, I think the saying is. So yeah, that is it for this video. Massive thanks to everybody that leaves the comments in all these videos, because that's how I do my learning, and lots of other people do as well. And every now and then it's nice to do a little revisit video, just a bit of a catch up on different things. I need to get this out of my sight because it's making me feel physically sick, so I need to get that away. I need to forget about that, just lock it away, so I can have counselling in 10 years time. It will probably build up by then. But yeah, that is it. I hope you enjoyed the video. If you did, give it a big thumbs up, and I will be back very, very, very soon with another Trying to Fix video. Take care, everyone.